And this will be us doing model 2. So the equation to our derivative, the slope of the tangent line, is a little bit more complex, and this is typically how it looks. Again, the first model that we did was a very simple scenario. It doesn't work out so simply usually. In looking at how many points that we have to account for, it looks like we do have a total of 8. They say x can't be 0, so we are not plotting any points on the y-axis where x is 0. We're only plotting at the 4 on the left of the y-axis and the 4 on the right of the y-axis. Now, typically when I do my slope fields and the work that they're looking for is you're gonna list off all of the coordinates of the points that you have to plot your mini tangent lines at. So on the right side, I've listed all of the coordinates of the points. And keep in mind, these are all of your x, y values. And you're going to be substituting in these x and y values into the provided derivative formula, the slope of your tangent line formula. So for instance, for the point 1, my y is 1, my x is 1. So looking at the formula here, I'm going to do slope equals 1 plus 1 over 1, which gives me a final slope of 2. And before I actually plot that, I usually just figure out what all of my slopes are. So for 1, 0, my x value is 1, my y value is 0. So slope is 1 plus 0 over 1, which gives me a final slope of 1. And then I would just keep the process going. 1 plus negative 1 all over 1, that would give me a final slope of 0. And here I would get 1 plus 0 over 2, which would give me 1/2. Whoopsies, sorry about that. So I'm going to go ahead and plot those 4 mini tangent lines. So at I'll start at 1, -1 actually. 1, -1, I have a slope of 0. So I'll draw a tiny horizontal tangent line. At 1, 0, I have a slope of 1, so something like that. And at 1, 1, I have a slope of 2, so connect that. All right. So relative to each other, they do make sense. Make sure your slope of 2 definitely looks steeper than your slope of 1. And at 2, 0, I have a slope of 1/2. So right, so again, make sure, relatively speaking, that your slope of 1/2 is not as steep as your slope of 1. Okay, and then I'm going to do the same thing on the other side. I'm just going to give myself a little bit of room. I'm going to list out all of the coordinates of the points. And then find the slopes. Okay, so at -1, 0, I'm going to have a slope of -1. Let's see, I have -1, 1. 1 plus 1 over -1. Okay, so that's going to give me a slope of -2. Looks like I have -2, 0. Slope equals 1 plus 0 over -2. So that's -1/2, and then I am missing the point -1, -1. And looks like that's going to come out to be another slope of 0. Okay, so then I'm just going to start plotting. So -1, -1, 0, -1, 0, I have a slope of -1. -1, 1, I have a slope of -2. And -2, 0, a slope of -1/2. So, okay. by the way, not to mislead you, they're not always, I can't always say that they are symmetrical. So that's just something to keep in mind. They were symmetrical here, but that is not always the case.